How do we grow this influence of black leaders, men and women, that can represent our industry inside the ANC, inside the policy-making structures?
Get to grips with the digital environment, put together best practices, what works and what doesn't, very importantly.
In the project that we're doing in Chatlat, we've created a linking bridge between those two little areas there. So it becomes a matter of just 10 minutes walk from one side to the other.
So my message to our CEOs and those chief investment officers is, where at the end of the day do you want to see your role?
So by treating all of our water back to a stage where we can bring it back into the process, we're in effect saving around about 35% of our water usage on site.
Good afternoon, ladies and gentlemen, and welcome to the Circular Economy Show here on greeneconomy.tv. My name is Gordon Brown. Before we talk about the topic and introduce our guest, let's have a quick word from the sponsors.
This show is brought to you by GBCSA's Positive Impact Magazine.
Right, I'd like to welcome my guest, as always, Chris Whyte, Director of the Africa Circular Economy Network, among many other seats that he occupies. Chris, welcome to the show, as always.
Thank you, Gordon. Always nice to be here.
So today we're talking plastics. It's the first of a series of shows in which we will have a look at the circularity discussion as it affects plastics. But today we're going to start with somewhat of an overview. We're going to ask Chris to give us a rundown of the different types of plastics. What are the most common applications for these plastics? Just how valuable are these plastics to us as a society, as an economy? And also to talk about the circularity that's existent presently in relation to each of these, and some of the key opportunities and how to fast track the circularity approaches that we use in relation to these. So without further ado, Chris, perhaps just start by giving us a breakdown of these key different types of plastics, please.
Sure, absolutely. Well, I think a lot of our listeners will understand that there are many different types of plastics. I don't think very many people understand just how many types of plastics there are. So if we look at the conventional system of looking underneath the lids or the containers that we're using, or on the labeling on the package, we will often see a recycling symbol, anything between a number 1 to a number 7. And that represents the main groupings of the different plastic types. So number 1 is our PET, as you'd get in your drinking bottle, the standard sort of Coke or water bottle. Our number 2 is going to be your HDPE, which is like your milk bottle. Number 4 is the LDPE, which would be your plastic bags. And then we have 5 polypropylene and 6 polystyrene. So the different ones that we have in there are number 3, which is PVC, polyvinyl chloride. And polyvinyl chlorides are hopefully going to be taken out of the system, particularly from a packaging perspective. They're very useful as an industrial plastic. But they do have certain problems in terms of their processing from the plastic perspective. And then we have number 7. And that's where the problem comes in. So number 7 basically means other. And number 7 essentially could mean anything that any plastic that's invented after 1987, or any combination thereof with plastics and other materials. So multi-laminates fall square into that. Things like Tetra Pak, which are cardboard, foil, and plastic. Chip packets, which is biaxially orientated polypropylene, which sounds like polyprop, but then that's also got foil in it. We have soap packets that are multi-layered with PET and LDPE and all sorts of different things. And then we also complicate that by putting in our inks and our adhesives and other components in terms of their manufacture. So those are the broad categories that we have. But there are thousands and thousands of types of plastics. So we often don't see in those symbols, we don't see polyacrylides, things like brominated applications, polycarbonates, nylons. So there are plenty more plastics than just the number 7 that we see.
Yeah, thank you very much for that. And so let's just talk about this. Some of the things you touched on there, the other plastics and the combined plastics and so forth. I mean, in terms of understanding the circular economy as it affects plastics, and we would understand that in, I suppose, simplistic terms, that we recycle. So we manufacture a plastic from petrochemical, turn it into what becomes an input. The input's then manufactured into a product. The product is used, and then end of life, we throw it away. Or in a circular economy context, we actually recapture that material and get it, break it back down into its primary parts potentially, and get it back into the system. I mean, how straightforward is that? How recyclable are plastics in the general sense? I guess the question.
Single-stream plastics are far more recyclable than multi-stream plastics, but we have problems within each of those systems as well. So if you look at PET, for example, we have a producer responsibility organization here that's been working on a voluntary basis for a while called PETCO, that they focus on PET. But the focus is not on PET, it's on PET bottles. So they've been supported by the bottling companies, and they look at the bottle side of things. So yeah, they report based on that fact. But PET is highly recyclable from that perspective, but there are different types of PET. PET is used in strapping, it's used in 25-liter bottles, it's used in 2 and 5-liter bottles for oil, it's used in thermoform or thermoset packaging. So a lot of the clear plastic clamshells that you would get your sandwich in or your salad in from your supermarket is in a thermoform PET, which is not recyclable. And there's different reasons why, because the primary polymer is processed in a different way, which makes it very difficult to then look at the application of that product through a conventional mechanical recycling process. But we also have problems with inks. So yeah, a prime example, there was a milk company that decided during Plastic Free July to change their milk bottles to a blue plastic, which was still the same plastic. It was an HDPE, but not understanding that a blue color is a lot less recyclable than a white or a clear color. And the impact of that in terms of the value of that product basically meant that the collectors were leaving that behind because it was of a lower value than a clear plastic. But then we have fillers. So we have filler products. A lot of bumpers are made out of polypropylene, but very few now are ever made out of 100% material. They're then blended with up to 30% filler, like a calcium carbonate or similar sort of product, which bulks up and adds weight to it, but it doesn't add any sort of technical strength or value to it. It's just reducing the amount of plastic. That has a knock-on effect in terms of their recycling as well. So those are the pure plastics, which are easier, but still complicated. So even in the polyethylenes, one has things like biaxially orientated polypropylene or BOPP. You have linear low density polypropylene. So there's variations within those themselves. And that creates problems in terms of any mechanical recycling, but it certainly doesn't have any impacts in terms of chemical recycling. So those are easier, but when you start looking at the multi-laminates, then it becomes problematic because it's virtually impossible to differentiate the different layers of plastic. And there's a lot of money that goes into multi-laminate manufacturing, and it's done for a good reason, because there's a lot of functionality behind different multi-laminates. They're not doing it to try and be unrecyclable. They've done it because it provides a function, whether it is UV protection of the product, whether it can breathe, whether it has a water barrier system to it. So there's a functionality behind it. But then we've complicated that further by then creating multicolored sort of bright packaging on it. So it's got to catch your eye. So our marketing is more of a problem than our plastics. And that also adds different chemicals. So now when you look at trying to break that down, there's a different composition because of the adhesives and the colorants in the packaging. So it's complicated.
Yeah, so so it boils down to, the separation issue as well, doesn't it? I mean, it's about trying to find ways to get all of the plastics recovered into a place where they can be properly sorted, and then each of these streams sent off in the most appropriate direction. I mean, for example, so yes, and what we have is a somewhat piecemeal approach, in the sense that some categories of waste, and it's equally some categories of plastic, are very well structured, and so there's a value to be offered to the collector for collecting certain things. And as you say, in other cases, a collector will leave it behind. But in a perfect world, if you had all the plastics brought into a sorting place, you could in fact take the single stream plastics, get them into recycling. You could take the non-recyclables and potentially push them into other valorizing opportunities, such as waste to energy. I mean, how far away are we from a system like that? Does the new regulation around extended producer responsibility trying to solve these problems, trying to just find a mechanism for collectors to bring all waste streams in for sorting, or is that not really something we're focusing on at the moment?
Well, it's important to note, I think, that the extended producer responsibility guidelines are specifically targeting those sort of issues, because it's been a historical sort of legacy issue, is that recycling is essentially what we call cherry picking. The recyclers or the waste pickers are only going to collect the products of high value. So they would collect the PET, which is the highest value, then your HDPE, and then your polypropylene. And pretty much the rest of it gets left in the environment. So let's not talk about the other components, the cardboard, cans, etc. Obviously, we're focusing on plastics here. So the problem is that the system currently is that about 90% of all the plastics that we recycle are done so by the informal sector. And they're not going to pick up something that doesn't have any value. So the EPR is designed around looking at underpinning the value of that at the base of the pyramid, so that we start getting a value for a product that the collectors will then start picking up these low value plastics. And it's not just the multi-laminates. So even if you look at something like the highly recyclable low density polyethylenes, there are within that streams of what we would call high quality and streams of low quality or zero quality that tend to be left in the environment. And the pickers know that. So the EPR is designed to try and look beyond that process and pull out the every different component. We have seen that already in our source separation programs. So whether you're Joburg, Cape Town, Durban, there are some initiatives in terms of source separation. And generally what happens there is that the dutiful housewife or homeowner will put all of their plastics into this bag. And that goes off to the sorting center, where generally 40% of what's collected is thrown away because it doesn't seem to have a perceived value. So that would include your multi-laminates, it would include your polystyrene trays, it would include your dirty film plastics, it would include your combination plastics. And what I mean by combination plastic is that if you look at a Coke bottle, the bottle is not just PET, because it's now got a PVC or another LDPE wrap around it, or the label. It's then got a polypropylene ring, it's got a polypropylene lid. So it's a mixed plastic, it's not a pure plastic. So it needs mechanical recycling to be able to separate those. And the more complicated that is, the less the value of the product. So we've got to look to understanding that EPR hopefully will underpin that collection value. But in doing so, we need to make sure that we have solutions that are going to be able to utilize those low quality plastics. So people say they're not recyclable. Absolutely. Everything is recyclable depending on your interpretation and definition of that. I see Takira has just put through a question based exactly on that. And that's exactly what we mean. So, low value plastic might not have a value through a closed loop mechanical recycling process, but it would certainly have a value as an alternative energy source or as a fuel source, or even some of the stuff that we're doing with our partners, where we're taking those problematic plastics and we're converting them into alternative building materials. So absolutely everything has a value, but you've got to create the front end and the back end to ensure that you are not just collecting a whole bunch of plastics for the sake of it. They need to find an ultimate solution.
Yeah, thank you, and for that question, Takira. And just a note to all viewers: please do post your questions, and we'll get to them just as soon as we can. So thanks very much indeed for that. Just further to Takira's question is the question of what are the most obvious factors? I know it's a multifaceted question, but what are the key factors that undermine value as far as plastics are concerned? I mean, you mentioned color, but what about other things like clean or dirty, or long time exposure, like plastics that have been floating in the ocean? How does this change the value of plastics, and what are those factors?
Well, there's a number of factors. First one is supply and demand before we even get into any level of contamination. And you see this across Africa. The work we're doing in Africa, you see, for example, flexible packaging or LDPE doesn't have a value in Kenya or Tanzania. So there are systems in place now to start looking at developing market applications. And for that, you need the technology and the application and the infrastructure to be able to process that. But then a market demand in terms of creating new products that will underpin that infrastructure and then therefore substantiate the collection side of things. But we see a lot of other problems. The multi-laminates obviously just very low value from the perspective of bringing it back into recycling. There's a lot of work that's being done internationally. I've got a meeting this evening with Purdue University from the USA looking at hydrothermal, low pressure hydrothermal chemical recycling. And there are different ways and the technologies are developing, but they're quite expensive. So the issue around dirty plastics is a problem because as soon as a plastic is dirty, it now needs to be sorted, separated, washed, granulated, and also color coded into either clear and colored or into sort of opaque and the different spectrums of the colors. So that all adds to the costs of recycling that material. But when we start looking at things like plastics that end up in the oceans, there's a lot more problems there because now you have salt, sea salt. And salt is a problem because salt is, chemical symbol for salt is sodium chloride, which means there's chlorides in there. So as soon as you do any heat application, you now have a chloride gas issue. But on top of that, stuff that floats in the ocean will have barnacles and seaweed and things growing on it. So now you have an organic component. So again, that complicates the system. We need to stop it before it gets into the sea. It's as simple as that. Once it's in the sea, there's very little one can do because your costs of processing and cleaning are highly expensive, and that detracts from the economic viability of any processing. River-based is not obviously as bad as ocean-based, but again, it's all an indicator of the fact that there's no perceived value of that plastic. If you look at any of the developing countries in Africa or Southeast Asia, if there was a value to the plastic, it would not be thrown away because people are desperate enough to put food on the table by any means that they can. And that's where extended producer responsibility is vitally important to underpin that collection value. But part of that has to be putting the infrastructure into place to add value to those products as well. You can't just collect it for the sake of collecting it. Yes, we can send it all to landfill, but we don't have landfill space. We don't have the management and the infrastructure for that. So we need to look at all those different components and bring them together. But ultimately, source separation is the key, is to try and get clean plastics before they get into the environment. And that's also needs to be underpinned through the likes of EPR. The problem, again, you face now is that through an EPR system is that some people would argue that the EPR now takes food out of the mouths of the waste pickers because now you're taking their livelihoods away. So you can't win sometimes, but we've got to look at it in terms of what's best for the entire economy. And part of what we're seeing through government is their perception and idea and understanding that we don't want to promulgate a system of low value. We want to start bringing those people in the waste sector up through the value chain. So instead of having tens of thousands of waste pickers out there, let's rather start looking at enterprise development where they now become the custodians of technology to add value to the different products.
So touching on technology, and I do want to talk about some of the actual good work that's happening at a circular level with some of the key plastics. But staying on low value plastics for a moment, I mean, just talk to us about some of the technologies that can be used and just how effective they might be and what some of the challenges are to bringing these technologies on stream at a sort of at a scale big enough and broad enough to really tackle valorizing these low value plastics. And I'm thinking in terms of things like pyrolysis and gasification and so forth. Let's spend a couple of minutes on those technologies and try to understand why they are not as broadly implemented as you would think when you first hear about these technologies. What's wrong with them?
Yeah, well, you've definitely primed this question, Gordon, because that's my pain point and why I have no hair left. There are technologies available for recycling of all plastic wastes. There is no such thing as plastic that cannot be recycled. But there are different levels again. Some of my colleagues in the circular economy might also say these aren't quite circular. No, they're not. So if you go from a plastic to a fuel, it's not going to go back into a plastic, which means it's not circular, but it certainly provides a value, and it provides an offset, and it provides a solution. So sometimes we need to take a journey towards circularity. We might not get to that entire path. But if you look at the costs internationally of chemically recycling products back into plastic, they are exorbitant. And the simple reality is that unless you have massive policy in place to drive those markets that will offset the control the oil industry has over the virgin price of crude, then we're in for a world of pain, and we're never going to get out of that. So the opportunity, if you look at things like waste to energy, I mean, we've got fantastic technology in this country. We've developed small-scale systems that would be able to take a factory off the grid using its own waste and plug it straight back into the grid. So great opportunities in terms of developing these different systems. There's gasification, there's pyrolysis. So you can convert it either to a syngas and then through a generator, you can convert it into a fuel. And that can then go into a multitude of applications. And there's huge opportunities around that. So we use a lot of fuel oil for things like our pico plants, which is our peak electricity generation systems in our metropolitan areas, which at the moment we burn diesel, which is just rank stupidity to my perspective. When we can use a problematic waste stream to create that same fuel blend at a higher CV level than you would get from diesel. So the opportunity then is to look at how you unpack them, and that's where the pain comes in. So the pain comes in because we have an outdated legislation. We have a system that doesn't understand technology. So as soon as you try and do anything thermally with plastic, the walls are thrown up because they're saying, no, it's now thermal conversion of plastic and it's going to billow clouds of smoke into the atmosphere. That's simply not true. There are fantastic systems in terms of pyrolysis gasification, which are closed loop systems, which do not emit anything into the atmosphere along those lines. Yes, there are some emissions. I won't say there aren't no emissions, but they are generally aligned with achieving at least US EPA type guidelines in terms of emission available allowances, and that's stronger than what we have through our own system. But then there's licensing, there's issues around certification and compliance, and so there's a huge amount of pain behind trying to put these projects together. And what we're trying to do is we're trying to drive small-scale projects that look at maximizing enterprise development. And when you look at small scale, it becomes very difficult. It's very easy for a big corporate to put down 3 or 4 million rand to do an environmental impact assessment and an air emission license or water use license, build the big infrastructure and all the rest of it. But when you're looking at the scale projects that you need across Africa and the developing countries, our legislation becomes the blockage. And we are working with them, and they are very open to try and do something, but it's going to take us a while. But there are some fantastic solutions that would look at basically valorizing all of our plastic wastes into opportunities that could create jobs, that would offset imports, that would offset our energy usage, and would stop the environmental pollution that we're seeing with regards to our plastics. So we've got to wake up to those opportunities.
Yeah, great. And let's hope that we make some progress there, and you make progress in your conversations there. So, coming across to a completely different perspective to the discussion is to talk about how designers of plastic materials and products can take on board the limitations that are created in recyclability from actions like fusing, actions like simply speccing the incorrect material in the first place. What is the how to what extent are people knowledgeable about the plastics, what's recyclable, what isn't, what factors undermine recyclability in this regard? And I'm talking about industrial designers, and let's talk about South Africa. I know we import thousands and thousands of products, but for the ones that are manufactured here, to what extent is there mechanisms to drive the thought process around the specification of the product and also the design of it from a recyclability point of view?
The drivers are huge at the moment. I think those who don't know, I mean, the International Panel for Climate Change issued their 6th assessment report yesterday or Monday, I think it was. And that clearly indicates the issues around the challenges in terms of things like plastics, energy from coal, and the other sort of high carbon applications that contribute to climate change. We've seen a lot of movement internationally, specifically through Europe. There are amazing directives that are coming through with regards to Europe, who are driving towards the new Green Deal, as they call it. And as part of that, design is a specific criteria and policy that's being constructed and developed that will guide corporates in terms of what they can and what they can't do. So that ties in with extended producer responsibility, where the big drive has really been looking around designing for recyclability. The big corporates for a long time have been saying, just recycle it. It's this is the solution. You guys are the naughty ones because you haven't been recycling it. That's not the point. I mean, the fact is that they've complicated that by looking at very few high level or high value plastics. So that design for recyclability is important, and EPR can provide a directing role in that by looking at a much higher level for low recyclable plastics, and then provide better incentives to higher recyclable plastics. That will encourage the recycling industry. That will create a better uptake and higher purity of products coming through the system. And you'll see an entire change in terms of the design engineers taking this thing through. We need to understand there will always be certain components that need to be done the way they've been designed because they comply with a specific requirement in terms of the product that they are packaging. And if they can't get around that, then they have to pay. The polluter pays, as far as I'm concerned. If they can't find another way around it, then you pay more for the packaging, which ultimately means that the consumer pays more for the packaging, not the producer. But if that's what we need to do, then that's what we need to do. But the focus is around that design. And we're seeing big policy directives in there. South Africa, we've just taken up our EPR directives in May. Now we need to align ourselves to reach the directives and the key performance indicators of those directives. So there's a lot of work that needs to be done, but we are seeing a big change now. And I think after COP27 in Glasgow, I think we're going to see a big swing, particularly because America has realigned themselves to the Paris Climate Agreement and to UNFCCC, and there's going to be commitments there. And we're seeing, strange enough, big commitments from China in terms of what they want to achieve by 2060. So there's a big push, and I'm encouraged by that. But we've got a lot of work to do, and the design is one of the key elements to that.
Chris, we've got a few minutes left. I want you to touch on this topic of biodegradable / compostable plastics. What's going on in terms of the availability of these products? Just how biodegradable are they? Is there such a thing as a compostable plastic? Perhaps just give us a few sense of the leading materials, ones that you are seeing in the marketplace, and give us your sense of this trend.
Yeah, it's a complicated one because there really isn't enough information in the country with regards to biodegradable. And I go into a supermarket and I'll see 100% biodegradable on a plastic packet. I know it's not. There's a lot of PLA-based systems. There's oxy and hydro biodegradable systems. And what they claim and what they can do are two different things. So if you took it into your home composting and tried it at home and it didn't break down within 2 to 3 weeks, then it's not compostable. So a lot of these are based on what we would call the requirement for industrial composting. So in Europe, they have industrial composting where you've got regulated temperatures and pressures in water, which accelerates the biodegradation. We don't have any of that in Africa or Asia, anywhere. So these problematic fractions go through into the so-called composting, and they just mess up the system because now you've just got plastic there. But there are some good ones in the market. And that's the problem, is that we don't have enough information in terms of which are the good ones. We don't have much in the way of processing locally, manufacturing locally, of the actual polymer. A lot of what we've seen happening in this country is people using existing plastics manufacturing equipment to use a compostable or biodegradable alternative in there. And those are generally based on a PLA type system, polylactic acid. But they confuse the system now. So now it complicates the recycling sector. Now you've got an additional plastic in there that's going to contaminate the conventional plastic recycling. So there's a lot of different options in terms of what can be done, but we need more information. And I've been working now with international governments to look at several really fantastic, good biodegradable systems that are made from plant fiber or plant-based systems that will degrade within 3 to 4 days. So the systems are out there, but we don't know what they are, and we don't have enough information locally to do that. So yeah, when you see something that's 100% compostable, try it yourself in your own garden. See if it actually composts or not.
Yeah, thanks very much for that. So we almost out of time, but I'd like to just quickly share Christoph van Skalkwijk has shared with us a product or a solution that he's come across in Europe, where they actually have a vending machine. I think a vending machine says it thinks it means it sells something, right? A vendor machine. But I think that the machine that Christo is referring to actually works the other way around. You put your plastic in and it gives you credit or money. Have you come across that system? What do you think about it? Is it applicable perhaps in the South African context?
No, absolutely. And there are reverse vending systems in South Africa. So it's certainly not unique. Obviously, we're not as advanced as they are in places like Europe. But it makes a lot more sense. A lot of people will advocate for the deposit return system, which makes even more sense. But the reverse vending machine will just read the barcode, and it will basically give a known measurement for that particular unit, and you will get a voucher to that amount. Fantastic system. I think it will work in sort of a first world environment. It will work in our sort of middle income suburbs very well. But it's not going to work in our rural areas. There's going to be big problems there. And I know some of the reverse vending machine guys have had problems because they don't understand the system. So they think it's based on weight. So they'll take a bottle and they'll fill it with sand and put it through the system, and there goes your machine, your 80,000 Rand machine. So it's a little bit complicated in terms of actual application. Theoretically, it works. The deposit return system would be far better, creating the value in something like that. And we know Coca-Cola has tried that and tested that in South Africa. We're still waiting to see the outcomes of that. But reverse vending definitely has a place. And we've got to look at all these different opportunities to capture each part of the market in terms of what's going to work for them.
No, 100%. Well, folks, that's all we have time for today. Thank you very much indeed to Chris Whyte, as always, for your valuable contribution. Thank you very much indeed. Join us next week, folks, for part 2 of plastics and the circular economy. We continue the conversation, same place, same time. Thanks very much indeed for tuning in.
Thank you.
This show is brought to you by GBCSA's Positive Impact Magazine.
How do we grow this influence of black leaders, men and women, that can represent our industry inside the ANC, inside the policy making structures.
Get to grips with the digital environment, put together best practices, what works and what doesn't, very importantly.
In the project that we're doing in Chaplat, we've created a linking bridge between those two little areas there. So it becomes a matter of just 10 minutes walk from one side to the other.
So my message to our CEOs and those chief investment officers is, where at the end of the day do you want to see your role?
So by treating all of our water back to a stage where we can bring it back into the process, we're in effect saving around about 35% of our water usage on site.